Hey everybody, Mr. Elliott here. We're going to be talking about solving some triangles, and this is the advanced lesson, so I'm going to be going a little bit deeper with this. These problems, these triangle problems, sometimes have some issues when you do a sine inverse. This comes up a lot, most commonly in the side-side angle situation, the funny situation if you order the letters around differently. And this is where that issue comes in. If you just use your calculator and you do sine of 30 degrees, I talked about this a little bit in class, I believe, but sine of 30 degrees works out to be 1/2, and if you do sine of 150 degrees, you get that exact same value of 1/2. Interesting. What about these two? Sine of 5, I get 0.087, blah, 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 blah. If I do sine 175. 0.087, the exact same, blah, 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 blah. So, what are you noticing about these two? These two values are supplements of each other. So when two values are supplements of each other, you're going to have multiple answers. So that comes up like this. If you had sine of A equals 1/2, well, you know that your calculator is going to tell you 30 degrees. That's all your calculator is going to give you. Your calculator is not going to tell you that the answer could also be 150 degrees. It's something you just need to know. You'll learn about that more in chapter 13 as to the why. Today, I just need you to kind of accept it, that is what's going to happen. This comes up most often in the ambiguous case, side-side angle. Let's look at 3 quick scenarios. Here's one where I have 7 inches, 9 inches, and 83 degrees. Now, because it's a side-side angle, you cannot use law of cosines to get this one off the ground, so you're stuck with law of sines. So on one hand, sine of 83 over 7 equals, this is my first x, so sine of x over 9. You work it out, sine of x equals 9 times sine 83 all over 7. X equals sine inverse of all that. And when you put this into your calculator, sine inverse of 9 times, Elliot's got to sneeze. Elliot's back in the game. Let's see, I had 9 times sine 83. Close that, close numerator, divide by 7, hit enter. Domain error? Oh, interesting. That means that for some reason, this triangle, totally impossible. So this one has no solution. So sometimes when you're given the ambiguous case, that means that solution, that triangle doesn't even exist. Amazing. So no solution situation. I mentioned in class, let's look at a situation that's going to be 2 solutions. I'm going to go 5 inches here, 7 inches here, 27 degrees here. And I'm going to get into the labeling this A, B, and C. A, B, C, A, B, C. And let's get this labeled. Side C is 7 inches. Side C is 5 inches. Angle C is 27 degrees. I actually like this chart. It helps me know to use law of sines. Sine 27 over 5. Sine 27 degrees over 5 equals, based off this, I have to hunt for A first. So sine of A over 7. This gives me sine of A equals 7 times sine 27 over 5, which becomes sine inverse of all this stuff, which means A is approximately clear this, sine inverse of numerator, 7 times sine 27 divided by 5, and it gave me 39.4635. Just for presentation purposes, let's just say it gave us 40 degrees. Just an approximation. Let's just say that. So if A is 40 degrees, or now if it's 40 degrees, that means that it could also work at its supplemental room, which would be 140 degrees. Now we have to common sense our way. On one hand, A could be 40 degrees. On the other hand, it could be 140 degrees. Is this physically possible? If one angle's 40 and one angle's 27, so far that's 67 degrees, which means angle B is going to be 113 degrees. Or if one angle's 27 and the other one's 140 degrees, 140 plus 27, that adds up to 167. 167 subtracted from 180, that's 13 degrees. Whoa. And both work. Both situations work. Amazing. So you then run through, so you kind of have two separate problems here. So I could use, so to find side B, I could go sine 27 over 5 equals sine 113 over side B, and I could find B that way. Or, well, I would do that to get this first answer. And then the second one, sine 27 over 5 equals sine 13 over B, and that's going to give me a completely different answer. So in a situation like this, because all the angles fit, this one has two solutions, and you need to find both solutions. Amazing. I love these problems. Okay, so we covered the no solution and the two solution scenario. Let's quickly just look at a one solution scenario. I guess this would be example 3. Let's say that I have 5 feet here, 7 feet here, and 47 degrees here, and I'll call it triangle ABC. So I start setting it up. ABC, ABC. Angle B is 47 degrees. Side B, 7 feet. Side C, 5 feet. So based off this setup, I need to go find C first. Angle C. So sine 47 degrees over 7 is equal to sine of C over 5. And let's just jump straight to the end. At the end of the day, C is equal to sine inverse of 5 times, start over. Sorry everybody. C is equal to sine inverse of 5 times sine 47 degrees all over 7. And then I pick up the calculator to do my decimal approximations. Sine inverse of 5 times, oops, start over numerator. Sine inverse of numerator, 5 times sine 47, close numerator, divided by 7, close denominator. And just for simplistic sake, let's just say this gave me 31. I rounded down. So now it could be 31, or 180 minus 31 is 149. So 31 degrees or 141 degrees. So C is either 31 degrees or 149 degrees. Start thinking about this. If one angle is 47 and the second angle is 31, does that give you enough room for the third angle? Yes, which means that angle works. What about this one? If one angle is 47 and then the second angle is 149, is there enough room for the third angle? No. We're way above 180 degrees. So this one gets canceled out, which means that there's only one solution. And you'd solve this normal like. You could then figure out that, let's see, these two add up to 78, which would mean this would have to be 102 degrees. And then you'd use law of sines to find angle A, and you'd be done with the problem. So the true issue comes in when you're doing these side-side angles. And like I said, if you're just going to be doing normal homework assignments, every one of those problems is just going to be a one solution type. But let me show you 3 examples here. Little extra homework for you, advanced people, because it's not going to show up on the homework. Here are 3 angle side-side problems. One of them is one solution, one of them is 2 solutions, one of them is no solutions, and you should work these 3 out and see what you get. Okay, that's the scenario with angle side-side or side-side angle problems. There are some pro tips that you're going to want to also follow, and let me show those to you right now. Hold on. I don't want Ellie in front. I want this thing in front now. Order. Move to top. No, not that. Elliot. Yes. Okay. Here are Elliot's pro tips. This entire lesson so far, I've been talking about the side-side angle or the angle side situation. We've used law of sines to find the missing angle, and then we determined if there was 0, 1, or 2 solutions. The first situation, we had no solution, so we were done. That second problem, we had 2 solutions, but we solved it twice, once for each triangle because there was 2 solutions. And then in that third scenario, we figured out there's only one solution, and then we finished off the problem normally. All right, other issues come up. First of all, angle side angle, angle side, an issue will never come up. Just use triangle sum theorem to find the missing angle, then use law of sines for everything else. It'll always work out. Side. If you never use law of sines, there will never be a problem. But law of sines is so much easier to use. First, use another hint is if you first use law of cosines to find the largest angle, it is then okay to use law of sines on the next angle. This advice B is how I go about solving these problems, because you're going to have to use law of cosines once, but if you use it once to find the largest angle, you're good to go for the rest of the problem. What happens if you don't follow Elliot's advice? Let's shrink this down. If you don't follow Elliot's advice, here is a side scenario where I did not follow my own advice. So I did not use law of cosines to find the largest angle. I used law of cosines ultimately to find what was the smallest angle. Oops. So I found that this angle was 21 degrees. So at this point, moving down to here, I know that A is 12, B is 6, and C is 7, and I also know that angle B is equal to 21 degrees. In this scenario, scenario 1, I then used law of sines to find angle W. Angle W worked out to be approximately 46 degrees. Triangle sum theorem, that means that angle M is 113 degrees. So here I have 46 degrees, 21 degrees, and 113 degrees to kind of match up with the picture. Scenario 2, well, what if I don't go finding angle W first? What if I found angle M first? Well, when I worked that out, M ended up being 25 degrees, and W is 134 degrees. So I put 25 and 134 here, and I got these 2 different solutions. But wait, that doesn't make any sense. Why doesn't it make any sense? We need to get Elliot back up in this picture. Sorry, everybody. Give me one sec. Hey, there he is. So I got two solutions, but this was a side, side, side triangle. And a side, side, side triangle, there can only be one solution. Yet somehow down here I got two solutions. So you have to common sense your way. Which one's right, which one's wrong? The sides were here first, and the biggest sides have to give the biggest angle. And if I look up here, the 12 is the biggest side, and over here, A gives me the biggest angle. Whereas over here, the middle side gave me the biggest angle. This one's the flop. So this is not the correct answer, in which case this would be the right answer. So advanced people, this is great advice to follow. Never use law of sines, but if you really must, use law of cosines to find the largest angle. Then it's okay to use law of sines on the rest of it. If you follow that advice, it'll always work. If you don't follow that advice, you're ultimately going to get two solutions due to the sine inverse, and you have to decide which one to throw out. That's kind of an issue. But if you just followed Elliot's advice, you don't have to worry about that. Here's another issue. This is the side angle side issue. Side angle side. Elliot mentions, once again, if you never use law of sines, it's never going to be a problem. But if you really want to use law of sines, first use law of cosines to find the missing side, then use law of sines to find anything but the largest angle. Oops, sorry about that. Shrink. So let's say I did not follow my advice. I used law of sines to get this 6.5. So at this point, I now have all three sides, 12, 6.5, and 18, 12, 6.5, and 18. But then I was like, I can use law of sines for the rest of the problem. So I use law of sines to find angle M first. Angle M worked out to be 18 point this degrees, which meant W was that. And so in terms of A, B's, and C's, I get this. But then what if instead of finding M first, I found W first? If I do that, I get an answer of 28.742 for W and 141.258 for M. And I put that in here, and it's the same scenario. This is a side angle side triangle, so there can only be one solution. And if there's only one solution, how do you know which one's right? The same idea. Biggest side, this 18 has to give the biggest angle. And in this case, this one here that I'm pointing at, biggest side did not give the biggest angle. So this one's out. So this one is the rightful solution. So once again, if you follow Elliot's advice here, and you never use law of sines, but you do this, or you follow this one, you'll get it right. And that's actually what I did here. I used, in the situation that didn't work, I was using law of sines to find angle, oh, this gets confusing, W. W was angle C, and that was the angle C is the largest side. So because I used law of sines to find the largest side, that's where the problem came up with. So if you just follow this advice here, it's never going to be a problem. Should be noted, when I worked this out on the normal lesson, I did something very similar with the side angle side. I just want to share this with you. I did the side angle side to get angle C here, which was the first thing I had to do. So I found angle C to be this, and then I followed my own advice to get the rest of the answer. But what if I didn't follow my advice? So at this stage of the problem, what do I know? I know that this is 7 feet. I know this is 5 feet. I know from part A, I'm going to use 4.7 as an approximation. I know that, and I know that this angle is 42. So I did this two different ways. In situation one, I went hunting for angle B first using law of sines, and I got 45.4. Then triangle sum theorem gives me a third angle of 92.6, so I put that up here. On this situation, I used law of sines, and I found angle A first. That worked out to be 85.3. Triangle sum theorem, that third angle is 52.7. And you're getting conflicting answers, but it's a side angle side problem, so you know it works. So you start doing the, well, did the biggest side give the biggest angle? And it did. Did the medium side give the medium angle? And it did. Did the smallest side give the smallest angle? It did. There's only one answer. How do you know which one's right? Truth is, I don't know. Just looking at this one, I'm not sure which one's right. But if I just would have followed my own advice and never used law of sines, it wouldn't have been a problem. Or if I would have first used law of cosines to find the missing side, which I did, then use law of sines to find anything but the largest angle. That's the scenario I did here. When I was looking for sine of A, that was the largest angle. That was the pitfall I did right there. On this one, 45.4 is not the biggest angle, so it was safe to go hunting for that particular angle. Because at the end of the day, a triangle can only have one obtuse angle. So as long as you don't do a sine inverse to hunt for that largest angle, it's guaranteed to be acute and it's guaranteed to work out. Anyway, your best bet is just to keep practicing these problems. The more problems you expose yourself to, the better you'll get. I'll put a copy of this thing on my website so you can print it out and follow this pro advice. And if you follow this pro advice, you'll never have a problem with these problems, and it'll be big fun. Anyway, thanks you for paying attention in advance. That was a long lesson. I'll talk to you soon. Bye-bye.